Okay, let's unpack this. We're diving deep today into, well, the wiring of your brain,
Right.
trying to figure out why some of us, chase massive risks while others just slam on the brakes.
Right. And the mission here, it's based on some pretty solid stuff. A big meta-analysis looking at what, like 43 risk-seeking
And
studies?
22 on risk aversion, yeah. Plus other key studies on things like addiction. We really want to pinpoint the brain systems involved.
And the basic idea we often start with is this dual system theory, this kind of constant battle, right?
Yeah, a tug of war. You've got the hot system, all emotion, impulse, wants the reward now.
And then the cold system, that's your strategic long-term planner, more cognitive.
What grabbed me straight away from the sources is
Yeah.
that risk-seeking and risk aversion,
Yeah.
they don't just, use the same circuits differently.
No, it seems they activate largely distinct brain mechanisms, which is pretty interesting.
Totally. So let's start with risk-seeking, that emotional drive.
Okay, so when you're actively choosing that risky option, the scans light up, particularly in the right insula and the left caudate.
The insula, isn't that involved in, processing uncertainty, your risk barometer?
Exactly. It integrates those O signals. And the caudate is key for evaluating incentives, the potential reward.
So risk-seeking seems pretty tied into the brain's reward network.
Reward network and also the salience network, the one that flags what's important right now, it suggests the pull of the reward can actually overshadow the perceived risk.
Which makes sense, but then you flip it. You look at risk aversion, the cognitive brakes. Completely different picture.
Completely different. Now you see activation in places like the left middle temporal gyrus, the MTG, and really importantly, the left anterior cingulate cortex, the ACC.
Okay, the ACC, and these are plugged into the cognitive control network.
That's the idea. The ACC especially seems to act like a modulator. It can actually step in and inhibit that risk-seeking drive. It signals, heightened awareness of the danger.
Okay, wait. You said distinct. The meta-analysis finding that really stood out was zero overlap.
Zero, yeah. Between the brain activities specifically linked to seeking risk versus avoiding it in these tasks.
Wow. So it's not just turning the volume up or down on one pathway. It's like separate teams.
Pretty much. Separate teams potentially competing for control over your final decision.
And that separation, that lack of overlap, it starts to explain why problems in decision-making can be so severe, clinically speaking.
Absolutely. If that cognitive control network, that brake system is weakened or damaged, you see the fallout in things like substance dependence, serious impulsivity issues.
There's that classic experiment, the gambling task.
Right, the Iowa gambling test, where you have decks of cards. Some give big rewards now, but have huge hidden penalties later.
And others give smaller, steady rewards, but lead to overall gains.
And what studies show is that substance-dependent individuals, the SDIs, they often behave like patients with damage to a specific brain area.
The ventromedial prefrontal cortex.
Yeah.
VMPFC.
Exactly. They keep picking those bad decks. High immediate reward, disastrous long-term consequences. It's like they can't connect the future pain to the present choice.
So that failure of foresight, the cognitive brakes just aren't engaging. But how can you, see that biologically?
Well, one way is through something called the somatic marker hypothesis. You look at physiological responses, like skin conductance.
You mean like sweaty palms, that gut feeling?
Basically, yes. Healthy individuals often show an anticipatory skin conductance response, SCR, before they pick from a bad deck. It's like a subconscious warning signal. But individuals with this kind of decision-making impairment, often linked to VMPFC dysfunction, they show a deficit in that anticipatory SCR. The warning signal isn't generated properly. It leads to what some call a myopia for the future.
A myopia for the future.
Wow. And computationally, or maybe economically, this impulsivity looks like steep temporal discounting. Precisely. That's the idea that the value of a reward drops off incredibly sharply the further away it is in time. So a small reward now feels way more valuable than a much larger one later.
And that steep drop-off is better described by a hyperbolic curve, not a simple steady discount.
Exactly. It reflects that dominance of the immediate, the emotional pull over the rational long-term calculation.
So what does this all mean when you boil it down?
Well, it looks like your willingness to take a risk really comes down to this constant push and pull, this competition between your emotional reward system and your cognitive control system.
And they're surprisingly distinct systems, neurobiologically speaking. You're either being driven more by the reward anticipation
Or more inhibited by the cognitive analysis of the potential downsides.
Okay, so here's a final thought then. This very imbalance, where the reward networks might mature faster than the control networks.
You see that pattern, potentially, in adolescence, right? Which could explain some typical teenage risk-taking.
Exactly. But maybe that same dynamic, the ability to consciously switch from an automatic, habit-driven choice to a more controlled, goal-directed one.
That switching ability, governed by these competing systems.
Maybe that's the key to personal control over risky choices, not just in youth, but throughout our adult lives, too. It makes you wonder which system is really running the show for your next big decision.
Food for thought, definitely.
Thanks for diving deep with us today.